Hello everyone. So in the last lecture, we discussed about insertion and deletion. In the last class, we discussed about the B tree, why we need a B tree, how it is used in a DBMS. I'll just explain some example with this track and this one. And we also take an example for like the block structure. So every data is stored into the block. So block is basically the union of sector and intersection. Okay. So in this we also discuss about the degree. So today I'm going to discuss about the insertion and deletion, right? So in the front of you can see there a question like degree d is equal to 2. Insertion keys are this one. Minimum key is basically here d minus 1 and the maximum is 2d minus 1. It is already discussed in the last class. So I'll take an example for one by one. So the minimum key is basically having here wait a minute. So minimum key is basically here 1 and the maximum is 2 into 2 is 4 minus that means 3, right? So whenever the key maximum key is there. So whenever I am doing an insertion, we have to be focused on to maximum keys, right? So when I am inserting here like 5, okay, so 5 is here. Next element is 3 is here, no problem at all. Next element is 21 is here, no worry here. But when the 9 is inserted here, so again the node is updated from here to here like 3, 5, 9, 21. Okay, so 4 element, but the maximum number of key is 3. So what we happen to do, 4 is divided by, we can here 4 is divided by 2, that is 2. So the second number of element is go to the upside because it is the bottom to up approach. So what will happen here? So 5 is going here. Again the left child is having 3 and the left child is 9, 21. Now you can see here the minimum number of key is 1. So minimum number of key is 1. Fine, no problem at all. Again 1 is here. So 1 obviously 1 is here. 1, 3, no problem at all. 13 should be here. Okay, so 9, 13, 21. Okay, so there are 3 elements here, no problem at all. 2 is here. So 1, 2, 3, no problem at all. 7, when the 7 is occur, so you can see it is greater than 5, so it should go to the right hand side. So 7 is here, right? But you can see this node is having a greater than maximum number of keys here. Maximum number of key should be 3, but here you can see here is 4. So what will happen? That second number of element is go to the upside. So when 9 is go to the up, and if you can see here, seven, 9 go to the 7 is here and 13 this one is correct and 21 is here. Okay, so this is the way the breakup is done. Okay, in this one you can see here, I'll explain step by step. So 3, 5, 21, now insert 9 is here, but the maximum we need 3, so the mid element go to the upper side. So 5 is here. When 2 is here, so 1, 2, 3, 13 is here. When the 7 is here, so 9 should be go to the upside. And the resultant is this one. Got my point? Okay. So this one is done. When this is done, now we have to be insert here 10. So when 10 is inserted here. So there is no problem. 3 element, 2 element, 1 element. But now I'm going to insert 1. So when 1 is inserted, sorry, 1 is already inserted. This one inserted is 10. Now after 10 we have to be insert 12. So 12 is going to be here, right? So when 12 is here, so like 12 you can see 12 is here. So here this node is having a maximum number of element, more than maximum number of element. So 12 is go to the upside. So 5, 9, 12, 1, 2, 3, 7, 10, because when it is breakup 10 is the left side of 12, 13, 21. Got my point? Now you have to be after 12 you have to insert 4. 4 is inserted here. Now you can see when the 4 is inserted here, this node is having a maximum greater than maximum number of element. So 2 go to the upside. When 2 go to the upside here, so 2 left child is basically 1 and 2 right child is basically 3, 4, but the upper side is also having a 4th element, which is greater than the maximum number of elements. So what we have to do, you can see it is happening here, right? So what we have to do here, we have to go to the second element 5 to the upper side, right? When 5 is going to the upper side, so 2 is here, 9, 13 is here, because there are 4 elements na? For 2, 5, 9. So 2 must be the left side, 9 and 12 to the right side. So here 9, 12, and again all the elements are adjusted here. And the last element is 8. 8 you can put here in there. 8. So you can see in this B tree, simply do the insertion, and it is basically divided whenever the maximum greater than maximum number of element, it is break up to the upper side. Got my point? Now, this is one more example here. It should be do by yourself and put the answer into the comment section. Okay. If you have any query, you can just ask into the comment section. Okay, sir, I am going to solve this problem and I am facing some problem. Okay. It is so easy, just like the previous one example. It is so easy. Just put it the element, and whenever the node is having the maximum number of element greater than maximum number of element, you can just break and put the second element to the upside. Why second? Because degree is 2. D is equal to 2. So the maximum key must be 3. So whenever 4, it is divided 2, that the answer is 2, right? Now, deletion. Again, you can see in the front of you, there one example for the deletion, and the degree is given here 3. So I told you that whenever talking about a deletion, you must be focused about the minimum number of key. So minimum is D minus 1, that is 2. So every node is having the minimum number of keys, right? So there are 2 type of node which we are going to element, which is basically in 2 places in a tree, either in a leaf node or either in an internal node. So today I am going to about all the cases about the leaf node only. Okay. So first of all, the target key is a leaf node. I am taking an example here 64. So again you have to traverse from the root node. So greater than 50, less than 80. So you must go here, greater than 60, less than 70, go to here 64. So here I can see here 64 is here. Got my point? Now you have to see this node is having the greater than the minimum number of keys. Yes. It is having a 3. We need only 2. So we just do simply delete this one. No need for this. Do nothing, just deleted it. If the node is having a greater than minimum number of key, you just deleted it. I am talking about the leaf node case. Okay. I'll consider here 3 more cases here. First, delete 23. So 23 is here. Right. So this node is greater than minimum number of keys? No. Because minimum number of keys 2. So this node is having a greater number of node? No. It is having basically the minimum number. So what they are doing? They are asking for the sibling. Okay, just borrow me 1 key so I can delete this 23. Okay. If it is having a greater than, they can give her to him. Okay. How? But not directly to them, because there is no path between these nodes. There is a path which through the parent. So what will happen? The largest element from the left side go to the upside, and the root node is go to the bottom side. So what will happen basically? I can draw here after deletion 23, 10 and 16. Here 4, 5, 6. Okay. And 10, 14, 15, and here 16, 20, 27. This is the updated one, this one. So 16 is going to the upside and 20 is going to the bottom side. Got my point? Next element, 72. 72. Again, it is having a 2 element only. So it is asking for the sibling. First of all, to the left side. So left sibling is told that okay, I have only the 2 child. I am not able to give you that. He is asking for the right one. Okay, you can give. Okay, yeah, I am having a greater than minimum number of keys, so I'll give you. Okay, so what will happen? The 77 is go to the up, 75 is go to the down, and 72 is going to be deleted here. Got my point? So again, I am going to update it this one. If I am going to write here, So this one is 60, 70 and 77. Here the updated is 73, 75 and here is 78, 79. Got my point? Again 65. 65 is here. So what they are doing? They are having only 2. Asking for left child, left sibling, it is having 2. Asking for right, it is having 2 because updated is 73, 75. I can just update it here. It is having 2. Okay. So what happened? So they are asking help to the parent. So what parent do? Parent only, you have to merge them, either left child or the right child. Okay. So what will happen basically when they are merging? So parent is going to the downward and merge them. Okay. So the new node is becoming like 60 and 77. 60 here, left child is 51, 52 and 70 is here. So 65, 68, 70, 73, 75 and this one is 78, 79. Okay. When they are merging them, you can just delete 65 because they are having a greater than minimum values. So this is the values update. So there are 4 cases. First one is the leaf node is having the greater number of minimum value, you can just delete it. If they are having a minimum value, they can ask from the left child. If left child is having a greater than minimum value, you can borrow 1 through the parent only. Okay. Similarly, if it is it does not have a left one, you can ask for the right one. Right one you can borrow through the root only. If the minimum number of having a key in on a left or right, so you can ask help for the parent root node. So root node is come down and merge them, and after that you can delete it there. Got my point? This is the cases which is going to be deleted the element from the leaf node. Okay. So enough for today. In the next class, we discuss about the deletion for the internal nodes. So there are 4 cases in the deletion in the B tree for the deleting node in the internal node. Okay. Okay. So these are the cases. Now I'm going to discuss about the deletion of internal node. Okay. So the same example, I'll just taken this one. Okay. So this I'll just taken here. This one. Okay. Suppose I just want to delete this 20. Okay. So this is an internal node. Okay. So how you can delete this 20? So for deletion this 20, if you delete this, so this node you can see here, like before this I can explain one more example. Suppose you want to delete this 70. Okay. So if you are going to delete this 70, so you just must be check it out. Okay, this node is having the greater number of minimum values. Yes, minimum key must be here is only 2. So how many element ways must be large? Like 1. Okay, so you can simply delete. But what will happen when this one is deleted? What will happen for these child? Right. So the maximum number of key must be kitni? Like 3, so 2d minus 1, so it is approximate 6, 5. So what will happen? The child must be merged here, right? You can delete this 70 and merge both of them. So when it is deleted, so the node is like, it is becoming like 60 and 75 and it is here the merge 64, 65, 68, 72, 73. There are 5 elements. No worry about it. Okay, got my point. Now, this one is the node, internal node. I am talking about the internal node. Second one example. I just want to delete this 20, right? If I want to delete this 20, so this node is having the condition false is minimum number of key. Minimum number of key is 2. But once I deleted this 20, it is having only 10. And if I can merge this, it is having only 5. So what will happen? So how you can delete it? You have to be just replaced with the leaf one. Okay, how you can do this? So 20 is here. What you have to do? You have to give 16 here and 20 goes down. Okay. So what is basically happen here, I'll just delete this one, is all link, and yeah, this one. Okay, so I'm going to delete 20. When I'm deleting 20, so the node is becoming like, so once I'm deleting 20, so 16 is going up and 20 is going down. So what is happening here? So 10 and 16, and here is 14, 15, and here 20, 23, 27. Got my point? And you want to delete 20. 20 is now becoming a leaf node. So when you want to delete this 20, you can simply delete it because it is going to the left node. Got my point? I'll take one more example. Suppose I want to delete this 95. 95 is also an internal node, right? But before this, I just want to delete 100. So 100 is deleted. So this is also a 2. This is also a 2. So what will happen here? If I want to delete this 95, if I 93 is going there, so what will happen? It is having only a one child, right? What we have to do? We have to go down and merge them. So when it is going to be merged here, so like 92, 93, 95, 110, 111. And after that, you can just delete this 95. And this child is connected for this one. Got my point? Okay. So insertion and deletion. Today I am discuss about the two topic, insertion and deletion. In the insertion, I'll discuss this one example. You can just take here d is equal to 2. The minimum number of keys is 1 and the maximum is 3. One by one, I can take a value here. When the maximum values are greater than 3, we can just split them. So here the 5 is go up, 1 or 3 here, and 9 and 21 here. Again 2, 13, 7 is here. When the 7, when their node are having again 4 element, the 9 is divided and go to the upside, right? So this is the example till now. Now when the 12 is inserted, so 12 is here, again 12 is go to the upside and the divided is this one. Again the 4 is here, 4 is having, this node is having a maximum number of key, greater than maximum number of keys. So what we do, we break and 2 go to the upside. This one is the example, right? So when the node is having a greater than minimum value, again 5 go to the upside, right? So 5 is going to the upside and the total diagram is becoming this one. And I can check here, the minimum element must be on the left side and the maximum greater than element is go to the right side. So greater than 5 on the left right child and the minimum is left child. Okay. Next one. This is the example which I will give you to as a homework. Again, the deletion example. Here we discuss two cases. First one is the you deleting the leaf node. When you are going to delete a leaf node, there are 4 cases, right? First one is node is having a greater than value. So if node is having a greater than value, greater than minimum number of keys, you can simply delete it. If it is having a minimum number of key, they can borrow from the either from the left child or from the right child. If it is having a greater than, they can give the key through the root only. If they are having a minimum key, both either left or either child, both are having a minimum number of key. So the root is coming down and merge them. Okay, these are the cases for the leaf node. And the internal node, if you want to delete the internal node, you can just carry either merging through the merging or you can go through the root node to delete them. Okay, I'll take you can just take the screenshot for this one. Okay, and delete some node. I'll just give you some homework. Delete the node one by one. So you can delete here 65, then 77, then 82, then 100, then 95, then 20. So these are the nodes some you can delete on this example as a homework. Okay, and after that you can put the solution into the chat box. Okay, so there are 2 lectures I will completed here, B tree, introduction of B tree, and the insertion and deletion of a B tree. I will discuss all the cases of deletion and insertion of B tree. In the next class we discuss about binomial heap. Okay, thank you so much.